Okay, we were on number 8 from your sheet. So it was a mass attached to a spring that had a spring constant of 20 newtons per meter, an amplitude of 2.8 meters, a velocity of 3.5 meters per second, and part A wants to know what's the mass. So if we call this our initial and we call this our final, then initially no speed, no mgh, but a half kx squared. Finally, a speed, no mgh, no kx squared, no E lost. So you have 1/2 kx initial squared equals 1/2 mv final squared. The halves go, and this time we're solving for mass. So it's kx initial squared over v final squared. K was 20 newtons per meter. X was 2.8 meters, and it's squared. And the velocity is 3.5 meters per second, and it's squared. And if you remember to square everything, you should get a mass of 12.8 kilograms. Okay, but there's a second part, and it's usually the second part that people mess up. So the second part says, at what location will it have a speed of 2 meters per second? Here its speed is 0, here its speed is 3.5, so somewhere in between it's going to have a speed of 2 meters per second. And we're asking what's the x. And it should be somewhere between 0 and 2.8 meters. Okay, so this is going to be my new final spot. And I'm going to keep this as my initial. Simply because I want to. Okay, so you're going to write out the whole energy equation again. 1/2 mv initial squared, mg h initial, 1/2 kx initial squared is equal to 1/2 mv final squared plus mg h final plus 1/2 kx final squared plus E lost. No E lost. So out here at my initial, there's no speed, there's no mgh, but there is an x. And in here at my new spot, there's a speed, no mgh, but an x. So we have 3 terms this time. 1/2 kx initial squared is equal to 1/2 mv final squared plus 1/2 kx final squared. The halves will still cancel, and this time we're looking for x final. So x final squared will be equal to kx initial squared minus mv final squared over k. So 20, right? Yeah, newtons per meter. X initial 2.8 meters, just meters, squared, minus the mass that we just found up there, 12.8 kilograms, times 2 meters per second squared, divided by 20 newtons per meter. Remember, what you get here is going to be xf squared, and it works out to be something like 5.28 meters squared, and then take the square root. So it should be 2.2978 meters. Okay, that's your number 8. All right, so hopefully those are pretty good. Now the only questions you have left to do on this stuff is the assignment, okay? And then, of course, your lab, which I will talk about separately.